As we continue working with sets, we are going to talk about the unions and intersections of sets. And in doing so, a union is when we have two or more sets, or a union of two or more sets. Is the set that contains all the elements of those sets. The symbol for the union is going to be what looks like a capital U, and you find the union of the two sets by listing all the elements that are in either of the sets. So that's how you'll find that union. And you can think of the union, the verb form of union is to unite, and unite means to put together to make a single unit. So therefore, we're taking the two sets and making a single unit, versus the intersection, that is where we have the overlapping. So the verb for intersection is to intersect, and intersect means to share a common area. And then intersect could almost seem like that's an N for intersect. So anyway, we'll do what we can to figure out the uses of these, but again, understanding that we will be going through the union and the intersection. And a disjointed set, we'll talk about that, is when you have two sets and there is no overlapping. They have no elements in common. And if we begin with this first example, in your left pocket you have a quarter, you have a paper clip, and a key, and that is in your left pocket. In your right pocket, you have a penny, a quarter, a pencil, and a marble. What is the set that represents the different items in your pocket? So what is the set that represents the different items? So we would want to have a union of our left and our right pocket to show all of the things that are represented. And if I do a little checking off as I go, I know that I have a quarter. I also have a penny. I have a paperclip. I have I just crossed off K for key, and I have a pencil and a marble. And that represents the union of that. That is all the elements of each set. And then if I was looking for, we didn't do this, but if I was looking to find out where do they intersect, the only thing that I believe they have that is in common for intersection is going to be the quarter. So that would be their intersection point. So there you go. That's how you would represent a union and an intersection. And as we write sets P and Q in roster form, what is the union of P and Q? Well, roster form. P is for all values of x such that x is a whole number less than 5. So my whole numbers less than 5 are going to be 0, 1, 2, 3, and 4. And then Q is going to be all values of y such that y is an even natural number less than 4. So an even natural number less than 4 would be, or less than 5 would be 2 and 4. Okay, so we've identified what those two sets are independently, and now it's asking us to find the union of those two sets. So the union of P and Q is going to be 0, 1, 2, 0, 1, 2, 3, and then 4. And I have represented all elements of each set. So there is my union form. When I'm looking at intersections now, intersections on the other hand are going to be where we have the overlap. So if I go ahead and get these in roster form so I know what they are going to entail, I have X is all values of X such that X is a natural number less than 19. Okay, all my natural numbers less than 19 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 because it said less than 19. And then we know that y is going to be all values of y such that it is an odd integer. All right, so that could be 1, 3, 5. It could be -1, -3, -5. So knowing what my integers are. And then z is going to be all values of z such that z is a multiple of 6. So thinking about 6, 12, 18, 24. So there you go. Those are some of the numbers that we would have. And of course, those would go on forever. But I want to know, what is the intersection point of x and z? And the intersection points of x and z. Z is multiples of 6. And then x were my natural numbers below 19. So it looks like I would have 18, 12, and 6 would be my overlap between x and z. So 6, 12, and 18. Then my next one is going to be, what is the intersection of y and z? And that is going to be y. Y is going to be all odd integers, and then z is going to be multiples of 6. Well, if we think about it, are there any multiples of 6 that would be odd values? There are not. So that's one of those things that would be a disjointed set because they do not overlap. So we have to be aware of that. So that would be represented as an empty set, that disjointed set we spoke of. Okay, so making a Venn diagram, and Venn diagrams are where we have these overlapping, and we sort of did this when we were talking about roster or subsets. So as I go and I make a Venn diagram, I'm going to show some overlapping values. So if I'm making a Venn diagram of A, and then it says A is one of the first 5 letters in the English alphabet. I'm sorry, A is X, such that X is one of the first 5 letters in the English alphabet, which seems like that would be A, B, C, D, and E. And then B is a vowel. So we know that B is going to be A, E, I, O, U, because those are all my vowels. We'll assume that they're not counting Y as a vowel. And then we know that C is going to be, is a letter in the word vegetable. Vegetable. And we want to, what letters are in all 3 sets? Well, making a Venn diagram, if I start there, and then not very good circles, but Let's see here. So if I go with set A, and I have, looks like I have an A in all of my sets. So that will fall in here because that is encompassed by all the circles. And then B, do I have a B in all the sets? No, I don't. B is only going to be in the A subset. And then C is only in the A subset. And then D is only in the A subset. And then E is shared in all the sets. So there we go. I have now accounted for subset A and many of the subsets or any of the items in B and C. Let me see. If we go to B, we know that we've already used the A and the I, and we have an IOU, which is not used in anything. IOU. And then if we look at set C, we've already accounted, we are missing the V, the G, the T, B, L. So there we go. We have all, that's how we would identify a Venn diagram showing the intersection and then the union of all our values. So our intersection falls in right here. That is in all three sets. So there you go. That's how you would make a Venn diagram. All right, so writing solutions of an inequality. Okay, so as we are writing solutions for an inequality, we can go ahead and solve the inequality first. And then we're going to identify it as either a union or an intersection of the two sets. So we can rewrite this absolute value as we learned before as -3. -3 is less than 2x minus 1, which is less than 3. And you can go ahead and solve, and we can do so by adding 1 to all our sides. You're going to have -2 is less than 2x, which is less than 4. And you go ahead and divide everything by 2 to get to further isolate my variable. And you're going to have -1 is less than x, which is less than 2. If we write that now as two inequalities, we can rewrite that as x is greater than -1 and x is less than 2. So we've solved that inequality, but now what we want to do is we're going to take this compound quality is an intersection of 2 points. So we can go ahead and write it as that, and we could say in set notation x such that x is greater than -1 with the union or and all values of x such that x is less than 2. There you go. That's how we'd write that in set notation, showing those two values that, yes, x is greater than -1 and x is less than -2, and that is a combination or an overlap to meet the requirements. And let's see here, take this next example. And we are going to begin by isolating our variable by subtracting 5 and then subtracting. Okay, so we are subtracting 5 from everything, and we have x is going to be greater than, or x is less than 6, and also 3 is going to be less than or equal to x. We can rewrite that now as two inequalities where we have x is greater than or equal to 3 and x is less than 6. And I believe here we should have a and statement, so we should be looking at a intersection. So when I write set notation x such that x is greater than or equal to 3, and the union, or I'm sorry, the intersection, because it's an and statement, when all values of x such that x is less than 6. So both of those must meet or be the criteria, so that's where they overlap because it's the intersection point. This last example, Let's go ahead and write that so we can start solving it. And again, the absolute value of 4x minus 6 is greater than 14, so then we know that it's also going to be less than negative 14. And go ahead and start isolating our variable, and we'll add 6 to both sides. And this will become negative 8 is greater than 4x, which is greater than 20, and divide by 4 to get rid of my coefficient, and then divide everything by 4, so I'd have negative 2 is greater than x, which is greater than 5. And I can rewrite that, of course. So we have x is going to be less than negative 2, and x is going to be greater than 5. So we have, for all values of x, such that x is less than negative 2. Now here, too, one thing to consider on our previous example, but this is going to be a union because it is greater than 14, so it's going to be moving away from y. And then for all values of x such that x is greater than 5. So we should be able to identify it there.